Hello everybody, Feridun from Total Electrical Training. This video is purely to teach you how to save energy and reduce your electricity bills. Now, there's a lot of talk about energy these days, especially since last year or so, when the cost of living went up and the rise in cost of electric bills in particular, and gas and everything else. There's a lot of talk about energy and energy bills and how to save it, and everybody's got their own ideas, and there's a lot of, as you would imagine, scams out there. So I thought it is my responsibility, I felt it's my obligation basically, to at least to my fans and people who know me, to raise awareness and teach them a thing or two about saving electricity and how to reduce your bills. There are ways to reduce your bills, and in this video I'm focusing on very important one. I made a video, to be honest, almost 5 years ago. As you can see here, it was published 31st of October 2017, and in that it is titled Electrical Principles, Types of Power. Now, in that video, which wasn't a long video, it was about 19 or 20 minutes video, I explained different types of power, different types of electric power. Now, in this video, I'm not going to bore you with all those nitty-gritties and details of the electrical engineering, because I know this will be shared with people who have little or no electrical engineering knowledge whatsoever. So I want to make it very simple, so everybody can understand what we're talking about and how they can save their electrical energy or their or reduce their bills, basically, at least their electric bills. Now, if you look at your bill, your energy bill, go to the section that is actually providing you with the information about your electric consumption and how much per kilowatt hour you've been charged. Now, there is a standing charge which is per day. You basically pay for every day, whether you use it or not. That's your just subscription. The main thing is your kilowatt hour that you use and the price per kilowatt hour. Now, the power suppliers, they have a lot of I wouldn't say maybe tricks, but there's a lot of sneaky ways around the way they bill you. Now, some put they jack the prices of some of them. They jack the price of daily charge, the service charges they call it, whatever they call it, is standard rate, and then they don't increase, or they increase a little bit on your kilowatt hour rate, so they can draw you in and sign a contract, so you can sign a contract with them and get the deal with them rather than their competitors. And some of them, they charge you different rates at night, different rates during the day, or different things. So if you look at them, they really, to be honest, there isn't much of a difference between one company or the other. On the surface, it might look like one very appealing to the other, but in the end, in a long run, it makes little difference. Now, that little might be very important to you. I don't know that. You should know, and you should dig into that further. But as far as I understood, and I've changed suppliers many times, in the past, but I haven't been doing that for the last at least 10 years or so, and I don't see any benefit in that. So the talk is not about that. The talk is about what you actually pay. When you look at the bill, it's charging you for kilowatt hour. Now, it's not the kilovolt amp reactive that you pay for. It's not the volt amp reactive that you pay for. It's nothing reactive. It's all wattage that you pay for. I'm trying to break it down to simple language, very, very baby language, so everybody can understand, because there will be lots of teenagers, lots of people who've just gone into their building their own homes, having their own individual lives and being independent, so they might not know my electrical terms. So I'm not referring you to this video that I published in 2017, although that video will be at the back end of this video, but for more details if you're interested. But I'm trying to make it simple so everybody understand. You're paying for wattage, but what you use to turn your lights on, to turn your oven on, to turn your boiler for central heating, for your cooker, your slow cooker, your Hoover, your anything you name it, washing machine, most of these things are inductive devices or appliances. What that means in simple terms is that you are paying for what you're not using. This is not a trick as such, but it is. It is and it isn't. What you use in your consumption, the real consumption that you have, like the brightness of these lights that we have in the room, or the energy that you actually consume to suck the rubbish from your carpet by using the Hoover, that power is measured in watts. But when you turn the Hoover on, or when you turn the lights on, or your cooker or your oven or anything else, there is a hidden power behind there that you won't see, but your meter still measures it as wattage, and that is a reactive power. It should be measured in reactive power, volt amps or kilovolt amp per hour or whatever. But it's not, because you only have one meter, one electric meter in your premises. If you go to big businesses, big industries, big companies, you'll see they have at least 2 meters. One is their power wattage meter, watt meter or kilowatt meter, and the other one is kilovolt amp reactive meter. It's the reactive meter. What happens for them, they only pay for what they use, which is that wattage. The reactive is basically returned back to the net. So you're not really using that, and the suppliers aren't supposed to really charge you for that. But in the domestic area, in your home, you don't have that. You have a watt meter or a kilowatt meter, basically, kilowatt hour meter, to say it correctly. And that only measures your, that doesn't just measure your wattage, that measures wattage and your reactive power. So let's say, for instance, you buy a bag of crisps. In a bag of crisps, that bag is not filled.
Combination of them.
That bag is not completely filled with crisps. It's probably, depending on how decent that company is, it can be from 50% of that bag full of crisps, the rest is air. So you're buying fresh air, but you're paying for crisps. This is the same with electrical bills. If you look at this triangle in my video that I published, for instance, just to put it into perspective, the bottom base of this right angle triangle, which is in green line, that is the power that you actually literally use. This red line, the vertical red side of the triangle, that is your reactive power. Now this blue one, which is the hypotenuse of this right angle triangle, it is what you pay for. So you're paying this much for this much power, but you're only using this green one, this green wattage. At this point, I hope you understand you are paying extra for what you're not using. So now for the rest of the video, I want to show and teach you how to bring this down. What you have to do, you have to pay for this green line, not this blue line, not the hypotenuse of this triangle, but the base of this triangle, which is what you actually use. So you're not tricking the companies or suppliers either. You're literally trying to pay for what you use. And they are the ones who have been tricking you. Maybe trick is not the right word, but it's a sneaky way to get money from you that you don't owe them. So what is the solution? The solution is to find out how much reactive power you have in your home, which is this red line, red vertical, which is measured in kilovolt amp reactive, and it's usually inductive, and that is why it's up, because if it was capacitive, this triangle would be flipped backwards, so this red would go down and you still have a triangle. You will still pay more than what you use, but it would be, instead of reactive, it would be instead of inductive, it would be capacitive reactive power. It's still a reactive power. So instead of giving you all these jargons for people who are not familiar with the electrical engineering, all you have to do is basically find out how much your reactive power is per day or per month, and bring that down. Now you can have a kind of estimated guess for a household, and say by average, if I'm using this much wattage, which is written on your bill, you can have a look at your bill and say I'm using this many kilowatt hour, or they're telling me at least that I'm using this much, so probably this much of it is reactive. So to bring this down, you need, because most of our household items or devices are inductive, we need a capacitive reactance to counteract with this and bring it down. To do that, if you don't understand this part at all, it doesn't matter, because what we want to do, we want to basically bring this down to flat, so, or at least as close as possible to the flat, to the horizontal line, so you pay for what you use. To do that, we need to correct this angle. What's causing that is this, because most of our appliances and devices in our household are inductive, and this is the symbol or the diagram for it, is inductive. And when it's inductive, what happens is that if you consider this blue sine wave your voltage of your supply, and this red one this green one your current is leading voltage, or voltage is lagging current by 90 degree, about 90 degree, depending on how much your load is, your inductive load is. Then what that does is creating that triangle of power, and so you pay more than what you use. If your load is capacitive also, it does the same, but it is doing it in a reverse way, meaning your voltage is lagging behind current by about 90 degree, depending on the size of this capacitance or capacitive reactance in your load. So these two are kind of counteracting with each other. This is what you actually have and you actually use inside your home, which is resistive or ohmic power, or the wattage that you actually have. And in that, the voltage and current are in phase with each other. There is no phase angle. None of them are leading or lagging. Voltage and current are in line with each other. They rise and fall together. And so the power, the red ones, the red sine waves are the power, either wattage, kilowatt or kilovolt amps. So as you see, these two are against each other, but most households, they don't have this item. All the appliances that you have mostly are inductive. So it's this and some of this. This is the useful part of it. This resistive part is the useful part, which you use for heating, for lighting, for anything else. And this one is not useless. It's there to do the job, but you're not actually using its power. The power is not what you see as useful in your house. So we need to eliminate this or reduce it to bring the bill or the cost of the energy down. To do that, we have to have this in the circuit. So you have to have a capacitive load in your circuit to counteract with this. How do we do that? If you're not an electrical engineer, it's not as easy as you think to just calculate that and put a capacitor there. But to make things simple for everybody, I've put a link to a device that is basically doing the job of this capacitive reactance to counteract with the effects of the inductive reactance, and as a result bring down the hypotenuse of this right angle triangle down to horizontal or almost there, so you pay for at least almost what you use instead of paying for what you don't use. There are other things you can do to reduce your bills, of course, going around the house and see what's being left on and things like that, or using energy saving lights and those kind of things, and I've got videos about those as well, comparing the energy saving bulbs or the halogen lights and the LED lamps, and so you know the differences. However, anything that is advertised as good doesn't necessarily mean good, so you need to dig into those things. Now, my job is to teach electrical engineering, and these things are my food, and I do these things for a living, so I know what I'm talking about, but I try to make this video as simple as possible for everybody to understand. Once again, just to recap, is that what you pay for your electric bill is this blue hypotenuse of this triangle, whereas what you actually use is the base of this triangle, the green line, the horizontal line. The vertical line, the red one, is a reactive power and is measured in kilovolt amp reactive, and we shouldn't really pay for that. But the watt meter that you have, or the kilowatt hour meter that you have at home, your electric meter in simple terms, is measuring this blue line, which should be measured in kilovolt amp, is measuring it in kilowatts. So it is a trick, and it shouldn't be that way, and you should have paid for that. You should only pay for this, but your meter is telling them that you're using that much. So you need to correct the way your meter shows by bringing the kilovolt reactive, this red line, down to almost zero. Now, bringing it down to zero exactly is almost impossible in practice. Now, to tell you why it's almost impossible, it takes a big lesson, and you need to know or have the electrical background. Well, because I'm making this video purely for everybody, whether you have a background in electrical engineering or you don't, so I'm trying to avoid those terms and jargon, and trying to stick to basic terms. All you have to, if you just take my words, you have to understand you can only reduce this and bring it as close as possible to the to zero. So your blue hypotenuse of this triangle will come down to the horizontal line. So your triangle from here, it'll come down to around here, and you pay almost as much as you use. At the moment, you're paying far more than what you use. So to do that, I have a link in the description to a device that can do that for you. Another way to explain this is this: if you're pulling a cart like this, the power that you really need to pull this is this much, but you're pulling this, which is the apparent power, and it is measured in kilovolt amp in terms of electrics. So this much is a reactive power. So the higher you pull your hands, the more energy you use, but you don't really need that to pull that much for this cart. To pull that, you only need to pull it from here. The longer you stretch down your hands, the less energy you'll use. So that's another analogy. There are other analogies out there. You can have a look at them, but you get the gist. Now, with this device that I mentioned, when you go to my website, totalelectricaltraining.co.uk, a tab there, it says energy hack. So you go there, and under that you'll find this device, and it tells you all about it, a bit more in details, and shows you what it is. But when you go to buy, you come to this device. Under there, you have to choose the type of the plug, whether it's EU or UK or US plug, and also under the color. This is not actually color. We couldn't change this. This is part of my WordPress in the background of my website, so I couldn't change that to the size of this energy saving device. So it says color, but when you hover over these items, and I put it here, hover over the colors to choose the right wattage or right size energy saver. It tells you this is a 1500 kilowatt, this is a 2000 watt, and 2500 watts or 2.5 kilowatts and 3000. So you pick the right size according to your home or household usage, and you can find that out by just having a look at your bill and doing a little simple calculations there to find out how much you use, your consumption is. So this is around that much that you can choose to save on your energy, and also protects your appliances from any unwanted power surges. I hope this video has been helpful and informative. If you found it informative and useful, please give us a thumbs up and share it with other people so people can understand what they're doing and save on their bills. This is a hot topic and people want to save their energy these days, and you do your part in sharing this to help others. Until next video, goodbye and thank you for watching.